All right.
Just a moment, let me. Oh, now you host, you should.
Yeah, I gave you everything.
Great. Great.
All right.
So can you see my desktop?
Yes.
Yeah. Yeah.
F5. Yes. So let's kick it off.
Yes. Let's do it.
Okay. Innovation. You know, we like quotes, and I found a very good quote. Ernst Hemingway. He said, "Never confuse motion and action." And you know, it's again, it's not trivial, and it's to me, it's about innovation. Motion is some changes related to you, and motion. This is what I understand from this quote, and the action is about causing change. This is a difference. So let's talk about innovation. Innovation is everywhere, and even some guys from Switzerland post office called me and said, you know, we have huge department of innovation, but we don't know what is this, and is it just some new things or not? Innovation is everywhere. Is everywhere. And the problem is, do we all understand what innovation is? And I think even internet is not clearly understands it. So let's have a look on some definitions of innovation. Cambridge Dictionary said a new idea or method or the use of new idea or method. Genius. You know, I like Cambridge Dictionary, but this definition, I think, not very deep. Oxford. The introduction of new things, ideas, or ways is doing something. Not something, as to me. By the way, if you want to say something, you can interrupt me, please.
Yeah. I just muted people for now because there was some background noise, but please unmute and interrupt if you need to.
Mm-hmm. So McKinsey, huge consulting company, innovation is a systematic practice of developing and marketing breakthrough products and services. But if I'm going to look for what breakthrough products are, I will find that this is something coming from innovation, let's say. It's not
So
exactly.
Hey, Anatoly.
Yes,
so
please.
I'm going to interrupt because this particular subject is one that plagued me for years at Intel. So I've been through all of these, and I hate those guys, McKinsey and company. They're sinister, straight up. A bunch of bad actors. And by the way, they are a threat to everybody who does trees and systematic innovation methods. I'll just tell you straight up. You come across any of these people from McKinsey, understand automatically that they are a threat to your business and what it is you are doing. Just telling you straight up, you can either take that as a fair warning and you've been now fairly told this, or you can ignore it and then act inappropriately and lose the business because these guys are sharp. actors, right? Straight up. And I've dealt with a bunch of them. McKinsey, Bain, what was the other one? Boston Consulting Group. And there are others, right?
Mhm.
I know how to vet them. I ventilate them in front of their clients purposefully. I brand strip them. And the reason for it is very simple. I am taking their competency off the table, right? And that's something I do all the time publicly and with Fortune 500 people. So if anybody hasn't seen me ever do this before, there's a reason why I do it. Number one. All right, so getting back to the definition thing. Without doubt, right? So this is something that I've brought up with Robert before, and even with Alex as well, right? So, and it was Rory Sutherland from Ogilvy who initially pointed it out to me. That was marketing and innovation are two sides of the same coin, and the part that I changed about it was emphasis on the coin, meaning it's about the money, and it's about the money for everybody concerned.
I'm
Now, hold
sorry.
on.
Now I'm going to interrupt you.
No,
Let
hold
me
on.
finish.
There's a point to
Let me
this,
finish
because
this.
I will finish my
slide.
comment. Everybody always
Okay.
tries to do this with me.
Okay.
Every time I'm trying to explain his background,
Yeah.
preference, so you understand what I had to go through, because I've had to deal with this for much longer than you even have known about trees. That's a straight up thing, and I was successful in doing it. That's another thing. Fair enough, right? So the thing about it is that when it comes to innovation, it is about something new. Absolutely true, right? And so thus in turn, you could use the term novel or change. Change is also another part of this. A change is being introduced, needs to be accepted, needs to be adopted if it is in order to become truly an innovation. Otherwise, it's just an invention, a nice idea. So this is the thing that I have always been concerned about with the trees community, systematic innovation community, was how are we defining innovation so that everybody understands it? So this has always been a critical subject for me, and I am deeply wedded into it because I have had to have so many fights over the very definition of this for 25 years. So I take it in a very passionate way, Anatoly, so you'll forgive me for my being quite direct and on point about this.
Okay.
So it's about the money, it's about the change, it's about something new, right, that's being introduced, and it is not an innovation if it is not accepted and adopted, period. Now, you can wrap, and here's the thing, I haven't been able to come up with a term, right, or a definition in the way that grabs a hold of all of those, right, and then wraps that up into a definition that anybody and everybody can go, oh, that's what that is. Because when we talk about innovation, it can be on the value proposition, it can be on the technology, it can be on the process, right? Or just in the system itself. It can be in the way in which you deliver it is an innovation in and of itself. How you communicate it, right? Also an innovation in and of itself, right? So you have to look at all of those things as a part of it. In particular, the work I've done with some people outside of the trees and systematic innovation community that have pointed this out to me, that the thing about this is when you start to, everybody's got a different definition in their head, right? And so you've got to lay down the foundation so that you shut the, the talking thing that's going on inside of their head. Well, my definition is different. So I caution about this because I have had so many issues with the very definition. And if you can't do this, you can't get everybody level set about all the next stuff that's going to take place. Anyway, I've said my piece about it, but it's a difficult subject, honestly.
Okay.
Okay, let's continue.
Thank you. So the next definition I found at Berkeley. Innovation engineering as a method for solving technology and business problem. Oh, I like it. It's already about problem solving and for organizations that want to innovate. This is, as to me, it somehow destroyed the innovation. I like this Lewis Duncan. He said innovation is the ability to convert ideas into invoices. I like it. And our definition, PRIZ, is innovation is a solution of somebody's problem that drives measurable financial gain. Actually, innovation, from our point of view, is the art of transforming problems into profit. If no one is ready to pay for this, it's not innovation. Some change may be nice, but not profitable. That no one wants to pay for, it means it's not innovation. What to innovate? What is the object? How to find the object for innovation? Our position that engineering system have voice. Engineering system, everything which was somehow modified by people. A river is not engineering system. A river with boat is engineering system. We all born as a non-engineering system, but since we visited dentist, we become engineering system. So engineering system talk to us through failures. Each time failure occurs, the systems tells us, guys, there is an opportunity to innovate here. And we not always understand the language of engineering system, and we spend money, spend time for fixing and forget about this, and we actually lose an opportunity. We should.
One question.
Yes,
Anatoly.
please.
So the way you have it written, so I absolutely agree with the first three bullets. The fourth one there, by fixing a failure, we waste money and lose opportunity. I think it's by not fixing a failure, we waste money and lose an opportunity. By not fixing it, right? Because a fix is not necessarily.
I will tell about this. I have a special slide about failure and problem.
I agree with the last one. That's fine. I'm all okay with that. But that not by fixing it just doesn't seem like.
We'll get there. We'll get there.
Yeah, we'll get there exactly. Yeah. So we need to analyze it to define problem and solve this problem. And this is a way to gain opportunity. Innovation, again, in this point of view, is the art of transforming failure into profit. How do we typically innovate or solve problems? We send the invitation, sit in the room, grab coffee, and people say it's brainstorming. I always explain, guys, this is brain guessing. If you are not working using special instruments, you are not managing your thinking by special tools, it's guessing. To say, let's change temperature, let's increase pressure, this is the same like to say 5 red, nothing there. Now, this one more point, I don't like when people want to solve problems in sessions. What does it mean? Tomorrow I will be problem solver from 2 p.m. to 3 p.m. It doesn't make any sense. Problem solving and innovation is a continuous. Just a moment. Just let me finish. Is a continuous process that require systematic work.
Okay, so yeah. What about when you have a team meeting, right? And where in particular, where like, for instance, when I do training, right, people come in as a group, right? They all got one slice of the pie of solving this particular problem on this product or this process node or what have you. And so it is a set period of time. We're going to use constructive confrontation, right, to make sure that we're all getting all the agendas on the table, right, as a part of the problem solving activity. Right. And so that we're all seeing the functional model, correct. And then that way, well, we solve a whole lot of issues because we're clarifying everything when we're building that functional model. So I guess that's the part where I'm like going, why would, and it may not be a single session. I agree with you, right, about that. But it absolutely can be a team-based thing, and it can be a set time thing where all that takes place. So I guess, you know, and this is coming from
Richard. I have the next slide exactly about what I what do you want to say? Exactly. Exactly. This is what people tell me. You are not right. We are getting to very good solutions. We are moving forward. Right? They move forward, but there is another problem: is a complexity versus simplicity. People generate ideas, generate changes, generate development. That this development typically becomes more and more complex, more and more complicated. Why? Because it's very easy for short time for team during this meeting to generate something difficult, make system more difficult. And it's very hard to make something simple. Example, car with sensors. You see, it's very clever to make hole, to drill hole in the body of car and insert the sensor.
So
Why we cannot just let me finish. Why we cannot use a car body as a sensor? Car body is a piece of metal and it generates a field. And if we insert some piece of something in this field, we will change capacitance. And we all know 100 years ago was generated a musical instrument, Termin Vox. It was invented 100 years ago, and you, with the hand, making closer and way you change frequency, and you generate music. The same could be used here, but we add components, we make systems more complex because we are not using, let's say, as to me, it's not, these sensors are not innovation. This is another product, but not innovation. Richard, would you like to tell something?
Oh yeah, because it's been actually the pattern that we've actually been going through this entire time ever since I brought up the issue around the definition of innovation. One of the things that is overcome, that you resolve as a part of the innovating process, is you are resolving conflict, contradiction, compromise, and trade-off. And if you aren't doing that, then you do not have an innovation, because that's exactly what I am doing in every single point that I have made when I have been speaking during the course of your presentation here, is I have been presenting conflict. And the only way that conflict gets resolved is that we have visibility to that conflict, that trade-off, that compromise, and then we get the innovative solution on the back end of it. And it's all a part of the process. And here's the thing, a lot of people have issues with conflict management. I do not, clearly, right?
Okay.
But everybody else does. They want to control everything. And I'm like, hold on. This is a process where we are all learning, and we are learning by managing, going through the conflict. That's how we do it. And that's the part where the complexity piece here that you just mentioned, to get to simplicity, requires to go through conflict. Go ahead.
Oh,
No, it was somebody on the phone. Richard, can I ask a favor? Can we continue that, because we do have a limited time? And we can have that conversation as much as we can after.
Let me continue, Richard. Okay, I prepared something that okay. So continuing about complexity, microelectronics. You know, because we don't know how to reduce RC delay, which is a key parameter of the microchip. We just increase the number of layers, interconnection layers. I remember I started to work in Intel. We had 3 layers, And when I retired, we used 16 layers. And I can tell you what will happen in 1-2 years. We will have 20 years and more. And what's happened? We increase the price of the device, dramatically increase price. Actually, we increase price according to Moore's law. And what's happened with the processes? Our number of operations with the processes only increases. It means we make processes more and more complicated. And you see, cleaning steps is about 1/3 of the processes. It means we generate a lot of defects and we should wash it out, and we don't know how to produce without chip, without defects, and we don't know good how to clean it up. So innovation is something, as to me, it's not innovation. So first of all, we said innovation is some failure or problems that we should solve, and this could be object of innovation. For instance, we have wafer, we have defects or particles on the wafer. And this, is it a problem we should solve? Sometimes people say, yeah, this is a defect on the wafer is a problem, which is completely wrong. Defects on the wafer is a failure that causes numbers of problems, like wafer attracts defects, or a process generate defects, or cleaning processes are not effective, and maybe defects or particles are too big. And if we can reduce the size of defects, they will not be impacted. Some other problems, commitment is at risk, and yield get reduced, and production cost increases. So we should understand clearly that failure causes problem. And the difference that failure cannot be fixed while problem can be solved. Like, broken leg. You can solve problem of walking, but you cannot return your leg into previous conditions. Failure cannot be fixed. And the problem is that very often people spend a lot of time and money for fighting against failure, which is incorrect. If you say the defects on the particles on the wafer are a problem, take tweezer and start to pick up and remove defects, which is out of sense. So our vision of the problem, our definition, the problem is not what you see, hear, or feel. The problem is what you should do as a result of what you see, hear, or feel. How to innovate? How to innovate? First of all, we have innovation is a movement to ideality, and we all know the ideality formula. The ideality is a number of functions divided by number of costs. There is, I found in the book by Isaac Buchman, he said ideality is the sum of a number of useful functions divided by sum of number of created components. Okay, and we proposed our version. This is sum of number of basic functions. So functions that goes directly to the product. A product is something that system was created for, like car created to move person. So move person is a basic function. So number of basic function divided by total number of components. And from this point of view, the innovation is always a reduction of number of components, and we can say increase in number of basic functions is necessary. So this is a movement to ideality. One of the instruments, very strong instrument, is a functional model, modeling, system functional modeling. What you see here is amplifier circuit. Everything is here. You can take 2 transistors, 2 capacitors, and 5 resistors, wires to assemble it. You assemble it, it's not working. What to do? You can use the method of problem solving when you fix wristwatch. You know how it is done. You always disassembly which wristwatch and assemble back. If it's working, it's okay. Not, you cannot fix it. You can use the same method here. You can bring a oscilloscope and a generator, but you need to know functions. What we can see here, we see here connections. We don't see functions. To understand functions of each component, we need to create functional model. And the functional model, I just remind you, this is our list of components of the belonging to the engineering system, technical system. Product is something that system was created for, and function connecting to the product calls basic function. And we have super system, with components that don't belong to the system, but impact activity of the engineering system. I don't know, like air, like humidity, and so on, so on. So functional modeling shows functionality. And generally, if you have such functional model, you can create amplifier. You can assemble amplifier. Let's pick up example. Trivial example, vacuum cleaner. I just picked up this picture because we have all components here. And a vacuum cleaner exists for to remove dust. It means dust is a product. So I built within our platform, PRIZ innovation platform, I built a functional model. You see components, you see dust is a product, and functions, useful functions, harmful functions. And when we create this this model, first of all, we understand how our system operates. We can calculate main parameters of the system. We can calculate functional and problematic rank of each component. And again, what we see, I'm so sorry, but how stupid we are. Our customer wants to remove dust only. And we say him, no, you should buy motor, you should buy fan, you should buy wire and dust bag. And he doesn't want motor. He wants to remove dust. But we are so not innovative. We created so difficult system. We need so many components in order to provide this function. And this is all a removal of these components are opportunity to innovate. System makes calculation of the model, and we see main parameters of our model, and we see the most functional and the most problematic component. And you see filter is the most problematic, of course, because air moves dust, and we insert filter which stops dust. Do we need filter? Do we need and we see the rest of the component, and the system gives us a recommendation what to do with each system, with each component. Let's try to create from this model wireless vacuum cleaner. So in this case, we need motor. We need change motor to motor DC. We need DC. We need battery. We need a DC converter. And if you have a look, you see we need much more components, and parameters are worse. So guys, this is another product, but this is not an innovation, because it's far from ideality. In order to provide the same function, we need much more components. Again, it's another product. If someone is willing to pay for this and keep it connected to the net all the time, we can make it. Why? Because we need battery. Why do we need battery? Maybe we can generate energy by another way. You know, we have person which moves a vacuum cleaner, a body of vacuum cleaner. He makes what? Why we cannot convert it into electricity? Yes, we can do it, and we can create this functional model. Person moves a vacuum cleaner, and there is some wheels or something that stresses or bends piezo plate, a plate made from piezoelectric, and piezoelectric generates electricity. And this electricity, static electricity, can collect dust. We just need to somehow to clean up this piezoelectric plate. And we also have belt rotating brushes. We have belt. Maybe we can use belt with cover it with piezoelectrics. By the way, this is already innovation, because we have much less components, much higher efficiency, much less components. For instance, this situation, we have piezoelectric belt which covered with piezoelectric material, and a person moves this body and moves a piezoelectric belt, and belt generate electricity. Electricity takes dust, and some collector, dust collector, removes the dust from this belt. So this is also innovation, because we are moving into a much less amount of components to supply the same function. Another example, a real example from microelectronics. This is wafer cleaning. You know, very trivial. Wafer rotates, and we pour chemistry on it. And of course, defects are remaining, and we created functional model. This is a hard work to create functional model, and this is a way to understand how system operates, and to understand the most functional components. If we want to improve something, we should think on the most functional component. If we want to make lean, reduce the number of components, there are some components with a very, very small functions. Maybe we don't need it. And if we have, if we need to solve some problems, we have the most problematic component. And airflow was the main problem. And when we stopped flow and increased pressure, we solved this problem. The second is a process. The process is something that converting energy into product. How we can innovate our process, how we can make innovative changes in the process. First, we should separate into operations. Any process can be separated into different operations. It could be production, microchips, or purchasing something in duty free. It doesn't matter. It's a process. So okay, we have operations. So what? The next step, we should define the type of operation. There are only 4 types of operations. The first is a productive type. This is irreversible change. Irreversible change, like to drill hole in the metal plate. Providing, this is some temporary change, like to mark this place where we need to drill hole in the metal plate. Corrective, since we don't know how to drill it clear and good, we have bars and we have to remove these bars. So due to our operations are not ideal, we need to make something additionally. And metrology. Metrology, we should measure is our hole drilled hole is on the place and right diameter and so on. When we define the types of operations, we can get into each operation, and within each operation, we can create functional model. And it makes sense because each operation has its own components and it has own target or product. As an example, this is what our platform is allows to create such, for instance, such flow. And for we defined type of each operation, and we created functional models for each step, for each operation. And now system calculates, gives the main parameters for this process, and gives some recommendations about each operation. And this process functional model helps us to make strategy, create strategy of innovation, how to innovatively change the process. First of all, we should remember that only productive operation that results in irreversible changes bring a value to the product. So therefore, only productive operations should be improved, developed. Please bring new technologies. Please work on the development of these operations. Improve and develop productive operations. Providing operations never bring value. I want to say lithography in microelectronics don't bring value, doesn't bring value. It means it's very stupid to develop and spend a lot of money into this operation. We should think how to eliminate providing operations because they are
I have a question about that right there.
Yes, please.
Since I am quite familiar with semiconductor manufacturing, got quite the track record with it, frankly. So when it comes to making such a statement that you just made about that, how well do you think that goes over with semiconductor manufacturing engineering professionals? How well do you think that defining in the way that you just did will go over with those folks? How do you think that they accept what you have to say?
Yeah, I know. I have ideas how to work, and I have some articles published about this. how to avoid usage of lithography. We should print it. We should. I have very good article where with 9 windows, I analyzed the future of microelectronics. Let's make another separated discussion about this. I would love. I would love to talk about this with you, with everybody. It's very, very.
Wasn't my question. Wasn't my question. Keep going.
Okay. So the next is a corrective.
Sorry, I apologize, Anatoly. If I understand your question correctly, there are 2 parts in this industry, right? The ones that actually interested in building the chip, right? The ones that create the processor, the memory, whatever they create, it doesn't matter. And the ones that create the lithography machines, right? So the ones that won't be happy are the ones that create the lithography machines, because they will start losing business if
I'm well aware of
that chip.
I have talked to this.
That's all it.
So I know.
That's all it means.
Mm-hmm.
Yeah, okay. But here's the thing. Here's the thing, right? That by the way that what Anatoly just said, what ends up happening when you're talking to semiconductor professionals, right, that have been in the industry for as long as they are, when you say things the way that you just said, it automatically raises resistance. And so I would.
Sure.
So here's the thing. I would argue and try and make the case for not necessarily going down that road, because it makes it harder for acceptance and adoption to take place, right? You don't want to be raising resistance. You want to be lowering the barrier to acceptance and adoption, right? As a part of, instructing people on the use of tools and how they help to enable them to get to the next step. Now, I'm not disagreeing with you, by the way, on what you had said earlier, which was, oh, well, here's what I've done as far as forecasting where this needs to go. I think that's a fantastic idea. But the truth of the matter is there is so much money involved. There's so much infrastructure changes, and the amount of influence that an engineer has that's in the factory versus somebody who's like, say, a senior executive vice president in charge of all of Intel R&D and technology development, who I used to work for, right? And how he would tell me, he was like, Richard, how are you going to be able to get this into my organization, right? When you're going to automatically piss them off the minute you start talking about it the way that you're talking about it. I'm like, that's a really good point, Sutherland. Geez, let me think about that for a bit. I raised that
and that's
legitimately.
In this case, Richard, it was mostly an example of providing operation, and not necessarily how and what is it going to be solved. I just want
everybody else to understand.
Yeah. Let's meet again and talk about this. Yeah. Okay. So our next step, corrective operation, guys. Corrective operation, for instance, in microelectronics, it's washing. It's washing. I've been working a long time in wet etch department, and we had 3 in sequence, 3 washing operation. It means we cannot wash it good on the first operation. We wash it additionally on the next operation, and it was not good enough. We entered the third washing operation, which is not innovation, which is very, very stupid. We should do nothing with the corrective operation, because when we develop our productive operation, and when we eliminate, or at least make much simple providing operation, corrective operation will disappear. The next step is next type of operation is metrology. It's good to collect data, but the question, do we really need this data? What do we do with this data? It costs a lot of money. We paid, microelectronics paid a lot of money to KLA. And so what? Do we do something? If not, please terminate it. If do, think how to terminate it.
Value of metrology operations in manufacturing, and I speak
yeah.
is What it provides for is it is a risk management tool for management and for engineering, because it basically tells you I have good product coming out of the backside of my process. If it fails, it tells me I have bad product. This is called binning. This is called die selection. This is called, ooh, I have a major freaking defect in my process. I need to shut the whole bloody thing down and find out where that problem is occurring. There's a whole bunch of things that metrology does that performs a business function necessary for the business to be competitive and profitable in the market.
Yeah, absolutely. So you just described the case where the information actually used, right? If it's used, amazing. No problem at all.
It's very good.
Yeah, but there's also, and here's the other thing though, even during the, see, because I used to use, it's not just that I have experience in semiconductor. I also have it in packaging as well as important system. So one of the examples, for instance, was we used to do ATE tests, which is earlier on in the process for boards, right? And the ATE test makes sure that I have actually got good, well, say a good wafer, right? Or a good board from the supplier, that everything sort of interconnects very easily. So it's an early on test. Before I start adding more components, costing me more money, before I get it to functional test, which is much later, right? And then we're powering up the board all full on and making sure that everything works, right? And it does what it says on the tin before we put it into the box and ship it. My whole point is different tests perform different functions as it relates to the overall build process and the overall shipping of, you know, final product. What I'm getting at is that there are different tests that you'll do during the middle of your process, that's where you're executing to, is the part that's so vital for the company to be able to help manage the risk of building poor product, because it's always an issue of the cost of poor quality, and the cost of poor quality is a death knell to any company. And by the way, I used to be a quality and reliability engineer, so when I say this, I'm coming from an informed point of view about it. So
yeah, Richard, I've been working as an integrator a lot of time, and I terminated a lot of metrology operations, and process only becomes more healthy after that, believe me. So let's continue. So this is the typical breakdown of different types of operation in semiconductor. It's about 60, let's say not more than 20% of productive operations. It means not more than 20% of all our time, money is going into value creation. All the rest is their time and money waste. So we should improve and develop productive. We should think. This is strategy. I'm not talking on throwing it out. I'm talking about strategy. We should think how to eliminate providing operations, how to eliminate corrective operations, and how to eliminate metrology. So these tools are provided by our platform. You can go. Our platform is integration of creative thinking tools, AI, project management, and proper documentation. We have 12 tools, and these tools we're told about functional modeling, and we have here helper, AI helper that helps to decide which tools we should start with. This is our useful links, our contacts, and just a few minutes about success stories. We have had a problem with the tantalum capacitor production. You know, there is a vacuum furnace where anodes, which are pellets built from powder, metal powder, mixed with binder. And this binder is deposited inside of the furnace. And this binder should be removed from the furnace and managers said we need to improve a process of washing of the furnace, of the vacuum furnace. They spend a lot of time, of course, again, they try to fix failure. With the PRIZ approach, we said, no, we don't need to improve washing. We should terminate washing. We should modify binder like this in order to eliminate condensation within the furnace. And this is what was done. When we created model, we understood how to do it, and we completed this project. Another thing is about cooling system. Cooling water is running through all the production and cools equipment, and due to corrosion, pH acidity increases, pH goes down, and we have some limits for water. And traditional approach, if pH reduces, we should increase it. Let's add caustic soda and increase pH. It's okay. We add it. We add it more and more in order to keep pH, and conductivity of water increases. And for conductivity also, there is limits. And if conductivity is too high, we cannot use this water because it impacts impedance of equipment, especially dry-etch equipment. And people said the problem is corrosion. No, the problem is then one part is anode and another part is a cathode. The problem is that there is different in potentials. This is what we understood when we created model, when we analyzed root cause analysis, we performed root cause analysis. And what we found, we found that we need to ground all parts of this system. This is what was done. Another example, very trivial in the very beginning of microelectronic process, oxidation of wafers within the diffusion furnace. It's 150 wafers in one stack. And bottom wafers is always worse. They have thicker layer of oxide, and standard deviation sigma is 2-3 times higher than the rest of the wafers. And traditional approach, the best solution was to use dummy wafers, let's say in the bottom of the boat, and let's say instead of 150 wafers to produce 120 wafers. Very, very good. We performed process functional modeling. You see what's happened. Process functional modeling showed us the merit showing problematic rank of operations, of different operations. And you see, 2 operations are red. All the rest are green. Which operations are red? Loading and unloading. What does it mean? It means that our problem is generated when we move wafers within the furnace. And we found very good solutions, very, very fast. Without...
By the way, on this one right here that you've just mentioned, I saw Samsung's solution to the same problem. They actually came up with, and they were actually 2 solutions they came up with. They actually were able to increase the volume of number of wafers that were actually getting depped, through the furnace. And at the same time, what they did was, and it was a really cool solution, where they just rotated the boat at the same time. It was a really cool solution that I saw. I was one of the PRIZ guys that did it at Samsung that I saw that they did on this particular problem. So this is interesting that you came up with, that's 20 million per year in furnace. Theirs would have been a greater ROI. Anyway, but this is not a bad idea.
Yeah, I'm not talking about money. I just want to, we proposed to disconnect feedback between thermocouple and furnace, because when we insert the cold wafers into furnace at 300 degrees centigrade, we cool down the first thermocouple, and instead of waiting for right feedback, another cold wafer comes to the thermocouple and said, it's cold, temperature is low. And all cold wafers runs going near this thermocouple. Therefore, the bottom of the furnace always overheated in the beginning of the process. And this is what causes of high sigma. And we should just disconnect feedback during loading and unloading. One more example, you will like this example, Richard. It's about the wafers that are broken wafers. Broken wafers on flash heating. We have chamber filled with nitrogen to prevent oxidation. Wafer is located on the boat made from quartz, and there are pins, centric pins. One lamp heats the wafer up to 400 degrees centigrade from the bottom, and another flash heating light on the top, which increases temperature very, very high, up to 1000 degrees centigrade within 1 or 2 seconds. It depends. Very, very fast. And it results in very, very often results in the broken wafers. And of course, task force, coffee, cigarettes, no solution.
No coffee, no cigarettes, no problem solving.
Exactly. When we analyzed it with the problem-solving tools, we revealed that the only way to destroy the wafer, to break the wafer, is their mechanical heat. And really, wafer is jumping, flying. Why? Because we heat it from the top, and we create different temperatures on the top and on the bottom. We have different pressures, and we create tornado. And wafer jumps, hit the bumps, and got broken. That's all. And if it's a reason, we have a lot of solutions. First, if it's jumps, we can fixate the wafer, or why it should fly, or we can reduce gas pressure. By the way, after analysis, we found that the tool having the lowest pressure was the golden tool, was the best tool. Or we can redesign a pedestal boat if wafer wants to fly. I like my students said, oh, we need 2 same lamps from the bottom and the top and on the bottom. Student who said it, he received 100 from me on the
Question: are these all Intel examples, or are they separate from?
Also in Intel, it exists.
Okay, I just wondered.
But you know, it's regular operation for any.
No. And you're correct. Absolutely true. No. They're common the processes are common, right?
Yeah, yeah. When you need to heat the wafer up and prevent diffusion. Yeah, it's so safety on stairs. Safety on stairs. You know, we had people start failing on new building on the stairs. Even it was converted into task force, and of course posters, keep handrails were everywhere, and of course it doesn't help. What we did, we analyzed. By the way, we used perception mapping, and we found that of course we proposed install sanitizers, and we proposed to place trash bins, and it's trivial thing. But what we found, we found that we need to redirect vision. We should make people watch a site on the wall. And what we did, we created small funny pictures on the wall, and when people come to the stairs, he started to watch on the wall on the pictures, even if he's familiar with these pictures, and actually automatically he grabs a handrail, and it helps. These are pictures were created in the Fab 28. Very nice pictures. So that's all. This is time for questions, if you will.
And I'll stop the recording for now. One of the reasons